Hey everyone, welcome back to the Systems Podcast, the show where we break down the systems behind modern software, startups, AI, infrastructure, and engineering at scale. I'm Mark.
And I'm Stacy.
Whether you're a software engineer, founder, student, or just someone obsessed with how complex systems work, you're in the right place.
Let's get into it.
So I want you to imagine that you're a senior enterprise engineer.
Okay, setting the scene. I like it.
Right. And you've just spent like 6 grueling months building, testing, deploying this highly customized middleware API for your company. Blood, sweat, and tears.
Oh, the classic 6-month sprint that takes a year.
Exactly. And then you wake up one morning and you realize that your entire project, your whole 6 months of work is completely obsolete.
Wow. Just gone.
Okay.
Because a competitor beat you to it?
No.
Yeah.
Not even that. Because 2 autonomous AI models just dynamically negotiated their own data protocol in like 3 seconds.
Oh, wow. Yeah, that hurts just thinking about it.
Right. But the thing is, this isn't some hypothetical sci-fi scenario anymore. That is literally the reality of the global economic refactoring that we are experiencing right now.
Right now, May 2026.
Exactly. We are completely shifting from, these rigid deterministic tools to probabilistic AI agents.
Like Google's new enterprise AI software.
What's Gamma, right?
Yes, Gamma. And numerous AI is another big one doing this. It's just completely altering the whole architecture of the workforce.
Okay, let's unpack this because right now, looking ahead to 2030, which, by the way, is just 4 short years away.
Which is terrifying, honestly.
Right. So every single engineer, every founder, every system architect listening to this deep dive right now is trying to figure out the macro trajectory of all this.
We're all just trying to read the telemetry.
Exactly. And the sources we're analyzing today, they present these 2 wildly different realities.
Which is super confusing.
It really is.
Yeah.
I mean, on one hand, we're looking at the potential for like an unprecedented economic boom. But on the other hand, it looks like a massive deprecation of human capital. Yeah. So what is the data actually telling us? Like, what's the real story?
Well, it depends entirely on which node in the global system you're sitting at, really. Let's look at the McKinsey Global Institute simulation first.
Okay, because they're the ones modeling the upside, right?
Right. They are extremely bullish. They project that AI is going to deliver roughly $13 trillion.
Wait, trillion with a T?
Trillion with a T. $13 trillion in additional global economic activity by 2030.
That is just a staggering amount of value.
It is. I mean,
Yeah.
if you map that out, it's a 16% higher cumulative GDP compared to today.
Wow.
Yeah. It's effectively adding 1.2% to global GDP growth every single year.
Just from AI alone, that's wild. And the adoption curve must be basically vertical at this point.
Oh, it's incredibly steep. By 2030, McKinsey estimates that 70% of companies will have adopted at least one type of core AI technology into their operational stack.
70%, right?
Yeah.
I mean, $13 trillion sounds fantastic on a quarterly earnings call, obviously.
Oh, absolutely. Investors love it.
But this is a huge, but then you run those numbers against the Goldman Sachs report.
Right. The Goldman report is sobering.
Extremely. When you look at their data, the scale of this disruption starts to look like, I don't know, a critical system failure. Goldman estimates that AI could replace the equivalent of 300 million full-time jobs.
300 million nodes just dropped from the network.
Dropped. Gone. They're predicting that up to a quarter of all work tasks in the U.S. and Europe could be fully automated.
A quarter of all tasks.
Yeah, but wait, pause right there. Because I have to push back on the math of these 2 realities coexisting.
What do you mean?
Well, Goldman Sachs also predicts this automation will boost the total annual value of global goods and services by 7%, right?
Right.
So how does an economic system survive locking out 300 million income-earning nodes? Like, if 300 million people lose their paychecks, who exactly is buying this 7% increase in global goods?
Yeah, that's the real issue.
Isn't that just a catastrophic feedback loop waiting to happen?
It's a brilliant question, actually, and it's the exact paradox that macroeconomic models struggle with right now. But if we connect this to the bigger picture, this isn't just about the raw, one-to-one replacement of human labor. It's really about the substitution of labor by automation to hyperscale innovation in products and services.
Right, at a near zero marginal cost.
Exactly. When you automate a really complex, repetitive task, you don't just save the cost of a single human salary, you're drastically reducing the latency of the entire system.
Oh, I see. So it's about speed and efficiency, not just payroll.
Yes.
Ah.
You speed up the cycle time from ideation all the way to deployment. Products become cheaper to make, services become instantly scalable, and that deflationary pressure expands the total addressable market.
Okay, that makes sense from an architectural standpoint.
But I mean, your underlying point is completely valid. That overall productivity boom, it absolutely requires the ruthless sacrifice of legacy human roles.
Which brings us to the specific jobs being deprecated. And I'm using the word deprecated intentionally here.
It's the perfect word for it, really.
Yeah, because if 300 million jobs are on the chopping block, we really need to understand which human systems are failing to compete with this algorithmic efficiency.
Right. Where are the bottlenecks?
Exactly. And we can actually break this down by looking at a business as a complete system stack.
Oh, I like this. Let's do it.
So let's start at the logic and routing layer, right? The white-collar data workers. There's this study from the University of Pennsylvania and OpenAI that genuinely blew my mind when I read it for this deep dive.
Because it completely flips the old assumptions on their head.
Totally flips them. The workers most likely to be affected by workforce automation right now, like today, aren't the ones doing manual labor on an assembly line.
Right, which is what everyone thought would happen.
Exactly. It's the educated white-collar workers earning up to $80,000 a year. They are the most at risk.
Yeah, if you look at the historical assumptions we've made over, like, the last 20 years, the consensus was always that the physical execution layer would go first.
Blue-collar jobs, heavy logistics, trucking, that sort of thing.
Exactly. Everyone just assumed white-collar office jobs were inherently safe because they required, quote-unquote, thinking.
Right. But it turns out a massive percentage of what corporate structures defined as thinking was actually just deterministic data processing.
Yes. Oh, perfectly said.
I mean, I look at these specific white-collar jobs like legacy APIs.
Legacy APIs. Okay, tell me more.
Think about it. If your entire desk job consists of taking data from one localized system, you check it against a static set of formatting rules, and then you just pass it to another system.
You're just a human API.
You are a human API. You are just passing state back and forth. You aren't actually transforming that data with, complex, nonlinear human intuition.
No, you're just routing packets.
Right. And if your job is just sorting and routing packets of information, you're going to be seamlessly refactored out by an algorithm.
That is a perfect structural analogy, and we're seeing it happen. Let's look at the specific roles the data points to within that logic layer.
Yeah, who's getting hit?
Accountants and bookkeepers, for example. We used to view these as highly secure professions, right? Bulletproof.
Oh, yeah. Always need an accountant.
But companies are rapidly migrating to cloud-based AI accounting services. And why? Because traditional double-entry bookkeeping is essentially just a state machine.
Debits, credits, perfectly structured schemas.
Exactly. And generative AI doesn't just read the ledger, it proactively flags anomaly clusters across millions of transactions in milliseconds.
Which a human could never do that fast.
Never. And the AI does it at a fraction of the cost with far tighter security perimeters.
Right. What about insurance underwriting? That was another one in the sources.
Oh, underwriting is heavily affected. The entire function of an underwriter is analyzing risk data and applying it within really rigid actuarial formulas.
And algorithms absolutely thrive on rigid formulas.
Exactly.
And research analysis, too. I mean, we used to think of analysts as these high-level knowledge workers.
Because they used to be.
Right. But the processing power we have access to right now, it can just handle the extrapolation and sorting of massive unstructured data sets without any human assistance at all.
And the AI doesn't experience cognitive fatigue at 4 p.m. on a Friday.
No.
Yeah.
Doesn't accidentally drop a cell in a massive pivot table and ruin the whole report.
Right. So that is the logic layer. But the disruption is moving rapidly up the stack into what we could call the interaction layer.
Okay, the interaction layer, like customer service.
Yes. Customer service and reception roles. These are largely being automated away because the vast majority of those queries are just repetitive and low variance.
Like, what are your hours? Or where's my order?
Exactly. They simply don't require high emotional or social intelligence to resolve. The source material highlights tools like AIM Reception, which are active right now in 2026.
Right, I've seen these. It's not your old sequential logic tree where a caller presses 1 for sales and 2 for support, right?
No, not at all. We are talking about multimodal LLMs with sub-second latency and vision capabilities.
Vision capabilities.
Yeah. They can literally see a guest, parse their intent dynamically, and hold a fluid, natural conversation. They just bypass that traditional decision tree entirely.
Yeah, that's wild. Okay, so we have the logic layer and the interaction layer, and then we drop down into the physical execution layer, right?
Yeah.
Retail and warehousing.
Right.
The data from Freethink estimates that 65% of retail jobs could be automated by this year, 2026.
65%, that's a massive shift.
It's huge. And we obviously see it with self-checkouts proliferating literally everywhere. But I always wondered about the shrink issue, the theft.
The loss prevention aspect. Yeah.
Right. I mean, the math there always felt off to me. Why install machines if people just steal more? But when you really look at the data, the algorithms aren't just calculating the cost of a stolen item versus a cashier's hourly wage.
Right.
The AI is actually recalculating the acceptable failure rate of the entire system.
That is exactly the mechanism at play. It's a complete paradigm shift. AI is transitioning physical retail from a zero-trust human monitoring model.
Where you pay a cashier to literally verify every single item.
Right, to a probabilistic loss tolerance model.
Wow, loss tolerance.
Yeah. The system knows that allowing customers to scan their own items increases shrink. It's a given. But the data proves that the overhead saved by removing human employees from the registers drastically outweighs the cost of the stolen goods.
That's crazy. So the human monitor is literally more expensive than the algorithm's margin of error.
It is entirely cold, but mathematically flawless.
It is. And we're seeing similar bypasses in physical sales roles, too. Like, salespeople used to be this essential routing protocol between a corporation and a consumer.
But not anymore.
No. Now, with built-in target marketing capabilities and predictive algorithms on social platforms, advertisers just bypass the human sales rep entirely.
They deliver custom, dynamically generated content directly to micro-segmented audiences.
Exactly. And in the warehouse space, the shift is just as heavy.
Oh, warehousing is moving so fast. AI already directs staff workflows and uses computerized systems to locate packages with, optimal pathfinding.
And the push toward fully mechanized autonomous retrieval is accelerating exponentially.
Add to that an MIT and Boston University report noting that AI could replace as many as 2 million manufacturing workers by this current year.
By 2026. Wow. So the physical jobs are far from immune.
Not immune at all.
But here's where it gets really interesting, though.
Okay, let's pivot to the good news.
Yeah, because once you strip away all these layers of the system, where humans were basically just acting as legacy OPIs, basic logic gates, or, repetitive physical mechanisms.
You're left with what?
You are left with the core architecture that AI absolutely cannot replicate.
The irreplaceable human architecture? I love this part.
Right. And there is one job on this safe list from our sources that is perfectly suited for the audience listening to this deep dive right now.
Oh, yes. Computer system analysts.
Exactly. That role is highly insulated. Let's break down exactly why that is, because it's crucial for you listening right now to understand this.
Okay, so no matter how much autonomous code generation we introduce, right, systems do not exist in a vacuum.
Never.
You have these massively complex software and hardware architectures that require constant maintenance, patching, and deployment coordination.
Right, because AI can optimize a beautifully defined process, sure, but it is currently terrible at managing the ambiguity of disparate legacy systems just crashing into each other in real time.
Precisely. If you have an AI writing a script, that's great. But who decides when to execute the legacy database migration while the third-party marketing API is unexpectedly hitting its rate limits?
Right. AI lacks that overarching systemic context.
Exactly. It doesn't inherently understand the business case of why a system needs to be updated, only how to execute the localized update.
So reviewing broad system capabilities, controlling workflows, scheduling cross-functional improvements, that all requires a human controller who actually understands the entire architectural goal.
What's fascinating here is that the human jobs that survive are the ones built entirely around managing the ambiguity that algorithms hate.
Algorithms hate untagged variables.
They do. AI requires clean data, tagged environments, and clear parameters. Human reality is incredibly messy.
Super messy. Look at the strategic, high-stakes professions, like lawyers and judges.
Oh, that's a great example.
Sure, an AI can parse 10,000 pages of case law in 2 seconds. It's way faster than any human paralegal. But arguing the nuanced defense of a client to a human jury.
Or a judge deciding on a sentence that will literally send a human being to a physical prison.
Exactly. That carries an unquantifiable human weight. It requires a level of ethical negotiation and fluid strategy that a deterministic machine simply cannot simulate.
And that same principle applies to corporate leadership too. Directors, managers, CEOs.
Yeah, you cannot write a linear executable script for true leadership.
No, because a CEO has to rally a team around a subjective mission. They have to project confidence and navigate really complex market psychology.
And furthermore, investors are not going to hand $50 million in Series B funding to an algorithm.
No, they are investing in the grit, the vision, and the adaptability of the human being driving the system.
I also love how the sources frame empathy and nuance as the ultimate defensive moats against automation.
Like HR managers.
Yes, HR managers.
Yeah.
If you just look at HR on paper, you'd think, oh, it's just payroll, compliance, and onboarding.
Totally automatable.
Right. But the actual function of a good HR manager is acting like a load balancer for human teams.
A human load balancer. That's a great way to put it.
Yeah, they're detecting the early, invisible friction of staff discontent. They manage complex interpersonal conflicts that just don't have a standardized error code.
Right. AI can screen the resumes all day long, but the human handles the unquantifiable bugs in the corporate culture.
Exactly.
Which naturally extends to fields relying on intense interpersonal connection, like teachers. We aren't moving to a fully digital teaching experience because teachers serve as critical, lifelong emotional reference points for students.
Yeah, AI can deliver facts with perfect recall, sure, but it cannot inspire a student to actually care about the material.
The same goes for psychologists and psychiatrists. Human mental health is just incredibly delicate.
I read there's facial recognition technology currently trying to develop, like initial AI counseling support by tracking microexpressions.
Yes, I've seen that too. But the human touch, the shared experience of consciousness, is an absolute necessity for therapeutic success. You can't fake that.
And even in highly technical physical fields like surgery, yes, we have microrobotics enhancing precision, right? They enable incredibly complex, less invasive procedures.
But the surgeon is the one managing the multi-level biological connections.
Exactly. They make split-second ethical decisions when a procedure goes sideways based on years of holistic, untagged experience.
And we also cannot forget the creatives.
Oh, absolutely. The artists and writers.
The source material points out something vital here. Even if an AI absorbs every book ever written in human history and synthesizes a flawless communication style, the actual magic remains uniquely human.
Yeah. The thrill of placing words in a specific imaginative order to evoke a shared spontaneous human emotion that is strictly our territory.
The machine doesn't feel the art it generates.
No, it just generates probable token sequences. Okay, so we have mapped out the architecture. We know what is being deprecated, and we know what is structurally sound.
Right.
So the logical next step for you listening is adaptation. How do you patch your own career stack before these automation deadlines execute? So what does this all mean for our timelines? Like, how much runway do we actually have?
Well, the timelines of disruption are executing way faster than most models predicted. According to the World Economic Forum, artificial intelligence is projected to replace around 85 million jobs by 2026.
And since we are sitting here in May of 2026, that is not a future projection. That is the current reality.
Yes, the first wave is actively crashing over the system right now. And looking slightly further out, PwC estimates that by the mid-2030s, up to 30% of all current jobs could be fully automatable.
30% of the global workforce. That is a staggering drop in nodes. Did the data break down the demographics of who is getting hit the hardest in these waves?
It did, and there is a very crucial demographic nuance here regarding gender impact.
Okay.
PwC found that during these early waves, the ones executing right now in 2026, women are actually at a significantly greater risk of automation.
Really? Why is that?
It's primarily due to their historically higher representation in clerical, administrative, and basic logic layer functions, which, as we established earlier, are the absolute easiest targets for current generative AI.
That makes total sense.
However, in the longer run, as we look toward the 2030s, the model shifts. Slightly more men will be affected as autonomous vehicles, advanced pathfinding, and heavy robotics begin deprecating the manual labor and logistics layers.
Where male employment is traditionally much higher.
Exactly.
Right. So whether you are managing administration right now or doing heavy manual tasks later, or just sitting in a comfortable white-collar data processing role, the algorithm is inevitably coming for your specific node.
It's just a matter of time.
So how does the listener actually upgrade their skill stack? What is the practical playbook to survive this refactoring?
The playbook requires a fundamental shift in how you view your utility. You have to move away from being a passive consumer of AI.
Right.
You can't just be the engineer deploying deterministic AI in your CI/CD pipelines anymore. The shift to autonomous, probabilistic agents requires an entirely different mental model.
Okay, so how do we learn that model?
The sources highlight the rise of next-generation, fully online universities designed specifically to facilitate this pivot. Because, let's be honest, the traditional four-year computer science degree is often too slow and too rigid to adapt to a technological baseline that changes every 6 months.
Right, because by the time the syllabus is printed, the framework they're teaching has already been deprecated by a new foundational model.
Exactly. So these next-gen platforms are utilizing what they call workplace alignment models.
Workplace alignment models, what does that mean practically?
They are constantly polling enterprise APIs and market trends to pivot their curricula in real time. They ensure you are learning the exact technical orchestration skills required in the job market at that very second.
Wow, so your education's agility has to directly match the technology's agility.
Yes. You need to become the engineer who understands how to string multiple localized models together into a cohesive architecture. You need to securely handle the latency and hallucination risks rather than just being a code monkey.
But it's not just the technical upskilling, right? Because if the AI is eventually handling the heavy code generation, the massive data sorting, and all the routine logic execution, then basic technical skills are basically becoming commoditized.
This raises an important question, and honestly, it's perhaps the biggest takeaway from all our sources. If AI is handling the routine logic layer, aren't what we traditionally called soft skills actually becoming the most critical hard skills an engineer can possess?
Oh, that's a brilliant way to look at it.
For decades, communication, cross-functional collaboration, problem-solving in unknown domains, and emotional intelligence. They were just seen as secondary bonuses to raw technical coding prowess.
Like, oh, he's a great coder and he's also nice to talk to.
Right. But in the era of AI, they are your primary differentiators. You have to be able to collaborate to run extensive research on emerging areas because nobody has the playbook for this new stack yet.
So your ability to communicate a complex, multi-model system architecture to non-technical stakeholders and to creatively solve the human problems that the AI uncovers, that is what will make you absolutely invaluable.
Completely invaluable.
Well, I want to leave you with a final provocative thought to chew on as we wrap up this deep dive.
Lay it on us.
We've talked extensively about how AI is going to free us from all the tedious deterministic tasks, right? It's going to automate the boring stuff so humanity can focus on highly creative, strategic, and empathetic goals.
You're right, the utopia vision.
Exactly.
Yeah.
But let's follow that logic to its endpoint. What happens when high-level creativity, intense emotional intelligence, and complex, ambiguous system management become the absolute baseline expectation for every single human worker?
Oh, wow.
Right? If you are forced to function at your maximum cognitive and emotional capacity all day, every single day, just to justify your position in the system, will we look back and actually miss the days when work occasionally just meant mindless, repetitive data entry?
That wraps up today's episode of the Systems Podcast.
If you enjoyed this episode, make sure to follow the podcast, leave a rating, and share it with another engineer or tech enthusiast.
And remember, great products are built on great systems.
We'll see you in the next one.